The idea behind the Elimination Bridge is to incorporate a continuum surface into a children's playground. The continuum surface allows the bridge to move and manipulate in more ways than a classic rope bridge would maneuver. It allows for various ranges of motion that add to the excitement and interaction with the playground. This project changes the traditional view of a simple playground while adding robotics and interaction to the child's experience. In the creation of the bridge, 3 standard servo motors and 1 push sensor were the electronics used in this project. 2 of the motors were placed at either end of the bridge, and 1 was placed at the center of the bridge. The 2 motors at the end were used to rotate and twist the bridge into various configurations as to discombobulate the subject to fall off the sides. The motor located at the center of the bridge was used to raise and lower a single shaft under the center of the continuous surface as to add confusion and become another obstacle that keeps any subject from crossing the bridge successfully. The push sensor is located on the floor at the entrance of the bridge and was used as the input to the system. Every time a subject stepped onto the push sensor, a counter was used to keep track of how many times it had been triggered. For this project, 4 scenarios occurred when entering the bridge. The first scenario is when no one has entered the bridge and the motors are at rest. The second scenario is when a single subject has triggered the sensor and 2 motors at either end of the bridge start to move. The 2 motors are given degree values that command them to move at plus or minus 30 degrees. Also, a random value, plus or minus 3 degrees, is added to the degree values to make the bridge jerk back and forth. The third scenario is when another subject has triggered the sensor and the 2 motors at either end of the bridge move quicker and larger random values, plus or minus 30 degrees, are added. The fourth scenario is triggered by the same input as the previous scenarios. This scenario moves the end motors to the starting position of 90 degrees and triggers the center motor to raise the shaft up and then lowers it back down. This raising of the center shaft makes all objects on the bridge to fall into the ball pit below. The components used for this project are 1 push sensor, 3 standard servo motors, a breadboard, an Arduino at Mega microcontroller, and a laptop.